Welcome back to 98366 MTA Networking Fundamentals. I am Thomas Willingham, and I'm here with Christopher Chapman.
Hi again.
We're here to talk about network services or roles and services that you may see on the network. Let us dive right in. So our objectives: setting up common network services. We'll talk about what those are. Defining more network services. So we'll talk about common network services, and then amazingly enough, we will talk about more. Then we'll also talk about defining name resolution techniques. So let's dive right into the exciting stuff we have on hand. The first one is Dynamic Host Configuration Protocol. In the last module, Christopher and I were talking about the fact that initially there were hosts files or LM host files that allowed for names and IP addresses to be associated to different systems. That is not this topic. That would be DNS. This is DHCP.
Oh, there you go.
So
that is a good one, though.
DNS is important, but we're not there yet. We're at DHCP.
It's on the slide.
No, it's DHCP.
It said DNS.
Oh, it did say, okay, you're right. It did say DNS, but that's not quite where we're at yet. We're at DHCP. Dynamic Host Configuration Protocol. So let's go back to, we were talking about manual entries, static entries. So initially, computers or devices had to have static entries for their IP configuration. Their IP address, their DNS information, their gateway, all of this information had to be added statically and configured manually on the system. DHCP allows for automagic configuration. Not just automatic, but there's magic in there. So it's a client-server protocol that enables configured client computers to obtain IP addresses automatically. Not just any device can get a DHCP address. It needs to be configured to receive DHCP. The information that it can receive is an IP address, a subnet mask, and if we remember from the TCP/IP section, the IP address uniquely identifies a system on the network. The subnet mask defines what the network address is versus what the host address is. We also have the gateway address. The gateway address, it allows or enables, if the address I'm trying to reach is not on the network I'm on, what do I do with that packet? Well, that gets sent to the gateway address. The DNS server address, which again resolves the IP address to name. DHCP server provides the following benefits: reliable IP address configuration and reduced network configuration or administration. Previously, Christopher has discussed being in an environment where he had to manually assign IP addresses.
The 200 some odd clients.
How'd that work out?
Well, I was a consultant, so great for somebody.
Because you were paid hourly,
Exactly.
And there were some hours involved.
Every time they put a new computer on the network, we spent 2 minutes, grab the sheet of paper that we had all the IPs on, drive to the office, find the computer, put an IP on the computer, go back to the office, send them a bill. It's a pretty decent consulting gig, actually, in terms of, effort for dollar. But not great for the customer. And not great for us if there was actually a conflict. The list we had was one list on paper. It wasn't electronic. It was updated by multiple people. It had been in use for multiple years. So the risk of having devices with the same IP, the risk of having IPs that were in use that weren't documented as in use, or vice versa, we start thinking we're out of IPs when we actually have 30 or 40 free ones because we're not documenting devices no longer in use. It's a nightmare.
So DHCP really addressed some of these issues and allowed for this to be much easier to manage.
Yeah, and we were able to finally, after about a year of weekly consulting spends by this company, able to convince them to spend the $100 some odd dollars they spent on a small piece of software that actually ran on a client to manage DHCP for the network.
Great. So the DHCP server. So before a DHCP server can start leasing IP addresses to client computers, that's what the system is called, is when a client computer receives an IP address from a server, it leases an address.
Yep.
The following steps must be performed. Well, so first of all, you need to install the DHCP role service. You need to configure an IP scope, so a range of addresses that the server will host. Once you configure the scope, you need to activate it. So you basically need to click that button that says, hey, let's go ahead and allow these addresses to be leased out. You need to authorize the server. Basically in your environment, say, hey, this is a valid DHCP server. For test purposes, I'm sure that people have brought up a DHCP server in their office to test. I want to test something. And they bring up a DHCP server, and Christopher, what do you end up with?
Oh, this is actually pertinent to everybody watching this video, because as you're watching this, if you're sitting at your desk thinking, I'm going to do what they're doing while they're doing it, let's just go along and go ahead and get this installed and configured. What you end up doing is creating what's called a rogue DHCP server.
Rogue!
A rogue, indeed,
Rogue!
Exactly. You're going to create a server that starts handing IP addresses out to your network that may not be IPs in the network as it's configured. You may cause network disruption issues, you may cause internet disconnectivity, or even other remote networks to be disconnected from those clients, or servers that say have reservations. I mean, it's a huge risk. I'm going to do some demos today with DHCP. Luckily, the activation and authorization components of DHCP now protect us from lighting up a DHCP server that is instantly sending out IP addresses. So you won't have the issues you had 10 years ago, but it's still a risk. So make sure if you're testing DHCP, do it on an isolated machine. We don't want to mess up any networks.
Rogue!
Yeah,
bad.
And the fun part, the flip side of this for the people watching this video, once you get that next level help desk troubleshooting support network administration job, and you're thinking this is going to be fun, and somebody calls you one day and says my computer doesn't get on the internet anymore, and you determine it's because it's got a DHCP address that's not on your network. Now you get to figure out how, on a network of anywhere from 200 to 5,000 computers, which one has DHCP installed on it.
Okay. How many emails have you received that said, please let me know who set up the rogue DHCP server that's handing out addresses? I'd have to say I've received 2 or 3 of those.
Yeah, I think I've seen a couple of those. I've been much more the person running through trying to find it. Like my computer, 3 or 4 people, and it happens over time. You'll get one person calling. This happened in my consulting role at this company as we put the DHCP server in, and we kind of had that transition phase. One person will say, my computer doesn't get on the internet anymore. Okay, easy enough, we'll go troubleshoot. Notice the IP is different. While you're there working on that one, a second person will call. My computer doesn't get on the internet anymore. Half an hour later, someone else will call. My computer doesn't get on the internet anymore. So you spend this time trying to track down this server as more and more computers are getting IPs from it and falling off the network. So I've had a fair number of those calls.
Well, and that goes back to the lease. So your lease is of a certain amount of time.
Yep.
And then when your lease is up, you go back through the DHCP discovery process.
Well, it's a configurable amount of time. So the default is 8 days, which is a good amount of time. And if you put up a rogue DHCP server, there are a number of factors that figure in. If you've brought up a DHCP server today, and all of your clients got a lease today, they're all going to renew at the same time. Now, a little technical fact about DHCP in Windows, they actually renew halfway through the lease. So if you've got an 8-day lease, on day 4, they're going to renew that IP lease. And that happens regardless. If you set it to a day, halfway through a day, they're going to renew that lease. So you hopefully avoid issues where, say, they run out. Even on a legitimate network with DHCP configured correctly, you don't have clients not getting DHCP addresses because something's gone wrong. They've renewed quickly enough and rapidly enough that they at least have a period of time to operate without a DHCP server if one's gone down.
And then it talks about configuring advanced IP options such as setting up a DNS server, default gateways, things of that nature.
Yep.
Demo.
Oh.
Christopher.
Oh, it's my turn.
It's your turn.
So we're going to run through those steps. We're going to start with installing the service. I've again got my demo environment up. We're going to go ahead and add roles and features.
Okay, actually, really quick, can we go back to the Server Manager?
We can.
This is the 2012 Server Manager dashboard.
Yep.
So those of you not familiar with Windows Server 2012, this is the new dashboard that you'll see. Great taste, less filling. It's pretty awesome. I personally have done some work on this Server Manager. The Remote Desktop Management Services component I helped
Over
create.
here under Is it somewhere? Which one am I looking at? Where's your piece?
You have to install remote desktop services first. But
Why is that? I would think you'd have that done by default.
Once we want to ensure that people know what they're doing when they install it, so they can look at it and go, "Wow, this is really good," as opposed to just stumbling on it.
Well, and as opposed to just installing everything by default, so that your server's slow right out of the box.
Exactly.
Every service known to man running right out of the gate. So
Okay.
we are going to jump into this from the standpoint of this is a relatively new server that I've put up that I don't believe, I need to verify this. I haven't installed a lot on here. I've started installing some prerequisites for what this server will eventually be. But for now, there's not a whole lot on it. It's a different wizard. If you're used to Server 2003, 2008, 2008 R2, this is dramatically different. So I encourage you, spend some time, get used to Server Manager, set up a test box, click the buttons, push the buttons and options and checkboxes and see what happens. Select a server, and in here we've got our first setup, which is roles. There's a DHCP server role. I get a box right away that says there are features that are also required for this role to function. In this case, the remote server administration tools for DHCP, which I'm just going to add. Next, this does not take long at all. I'm not going to install any separate features, and install. Now, one of the nice things about Server 2012, on a kind of a side note, this is going to run, and as you note down here at the bottom, you can close this wizard without interrupting running tasks. I can close this, and it's still doing what it's doing. I can go do something else. I can actually rerun the roles and features wizard. In 2008 R2, I would have to wait. I'd have to sit there and wait for that window to get done. So it shouldn't take too long. It will actually notify me as soon as it's finished. I have up here notifications, feature installation, and this one is running. It gives me real-time status.
And then one thing to note on these is some role services that you install are going to require a reboot.
Yes. DHCP does not, I don't believe. I'm
I
going
don't believe
to say it does not.
I don't think it does.
It's weird. I've done this 1,000 times, and my brain is still like, are you really
Maybe,
sure?
maybe not.
I don't think DHCP requires a restart. So we'll wait for this to get installed, and then we'll move on to the next step, which is, actually I think this might, what's the demo on this one?
Install and view the
install and
DHCP
view.
service.
So we do have to wait, because I know that in a subsequent demo, we're actually going to configure a scope and look at the activate and authorize options. We're not going to authorize this one because I don't want to mess up my test network, but that's the saving grace. I can do this confidently without worrying about setting up a rogue DHCP server.
Rogue!
But don't try this in your enterprise without a separate network. Look at me talk. Oh, it won't take long. This is going to be fast. And we wait.
Wonder if we have Jeopardy music that we can install.
That would be
we
terrific.
Can overlay here.
Well, in the meantime, what I can do as a refresh to one of our previous conversations, I'm going to pull this up. Let me configure it real quick so you can actually read it on these screens. And 24. Click OK. And we're going to look at ipconfig. Oh, no, you know what? Let me come back to what I was doing. I'm going to go to a different computer and do this on a different computer that has a DHCP assigned address, I believe. Yes, DHCP enabled. Now, a couple of interesting things to note about this screen. It is enabled. It has an IP4 address. Notice it says preferred. What does that preferred mean? Do we know?
People like it better.
People like 10.0.0.39 better than all of the rest of the 10.0.0
Well, yeah,
addresses.
it says right there, preferred.
In this case, for my particular setup, I have this computer set up so that I can get to it from outside through various different protocols. I have a reservation.
For dinner?
In DHCP.
Oh.
So when we get into DHCP, we'll look at what that means, and I'll show you what I'm talking about here. For now, this is the address assigned by DHCP. I can see that DHCP is enabled. And at some point, oh, it's not on this interface. That's what you get.
Okay, real quick before you go, notice auto configuration enabled by default. Yes.
Yes.
APIPA.
APIPA, indeed. We learned about that in a previous module.
And we're going to talk about it a little bit more here in just a bit.
We are. We're actually going to talk about how to turn that off and why it may not be a good idea for your network.
Okay.
As it relates to DHCP, in fact. What you can see as well, lease obtained and lease expires. So July 20th it was obtained. August 18th it expires. Again, it's going to renew at certain points in that, throughout that lease. But this is a good way to see, it's a good way to put pieces together if you're troubleshooting a rogue DHCP server, or even troubleshooting an issue with an existing DHCP server that's come down and is no longer servicing addresses. You can use the obtained and expires to figure out what's happened. Use a computer that is no longer getting DHCP information that's probably been taken off the network that you'll see in a PIPA address on. It will have stopped getting your network. It will have assigned itself in a PIPA address. You can then go to another computer that still might have network connectivity or internet connectivity, do an IP config all, and you'll notice the lease hasn't expired yet. So it's still using an IP that it got from DHCP, but hasn't had to try and renew it. Let's go back to here. Close that because it's not what we need. Feature installation has succeeded. I can now manage DHCP on this server. So here we go. DHCP is installed. It's on this server. I have both IP4 and IP6 scope options. Server options we talked about. You can set gateways, you can set DNS, you can set up multiple different options. We're not going to go to this yet. We're going to configure this in a little while when we set up a scope. But you've now seen how to install it and what the management console looks like by default.
Okay. So now let's talk about the process for leasing for that lease.
Yep.
So we've talked about a lease, a client getting information from a DHCP server. So let's talk about that process. And that process is Dora. Isn't that little fish from Nemo? Dora?
It is a fish in a movie.
Okay. But that's not what we're talking about. That's not the Dora we're talking about here.
I wish, now that I think about it, I wish I'd built the slide with some sort of tie-in to that. That actually would have been funny.
The Nemo, yeah. So DHCP sessions use a four-step process known as DORA: discovery, offer, request, and acknowledgement. So if we look at the fancy graphic that we have here, so we see a client. Now this represents a client coming online.
Yep.
So it's booting up. It's been turned off, and at this point, it may or may not have an existing address.
Mm-hmm. Exactly.
So the first thing that happens is it basically says, "Hey, Ollie Oxenfree, are there any DHCP servers out there that can hand me an address?" So that's the DHCP Discover packet that gets sent out.
And it's a broadcast. So that goes out to every computer on the network within what's called the broadcast boundary.
Typically not routable.
Not routable at all.
So a server on the same subnet would say, "Hey, I'm a DHCP server. Here's an IP address for you." Now, it's possible that this client may receive multiple addresses back from multiple DHCP servers.
Absolutely.
So that's the DHCP offer. The client then selects an address and says, "Thanks. I would like to use that DHCP address." And then finally, DHCP PAC, "Hey, pleasure doing business with you. I acknowledge that you are using that address."
And another note, the request, again, is a broadcast to let the rest of the network know I've chosen a server and an IP. That's what we're going with. The acknowledge, the server's actually going to resend the same information again as well. It's going to say, "Great, we're glad you've taken what we want. We're going to make sure you have the right information."
And I would just like to call out that the men behind the curtain, have informed me that the fish was called Dory from Finding Nemo.
Oh.
Dora is the Spanish girl explorer.
Well, now you can see, this is actually a good gauge of, you can see how much time we get to do things outside of what we're doing.
Yeah.
We don't get out much, so we at least have that excuse, I think.
Demo. I think it's demo time.
Oh, is it demo time?
Add a DHCP
All right,
scope.
we're going to add a scope. So I'm already on the interface. I've still got the same console up I had up before. We're going to, so a couple things to notice. Notice the little red arrows, these little red down arrows. I wish I had zoomed it on here that I could zoom in and take a look. These are currently not serving requests. There aren't any scopes, but even if there were, and we're going to go ahead and create a new scope, we'll show you what that changes, if it changes anything. Main office. You can give this any name you want. It's not function impacting give it a start IP address and an end IP address. Now, this is where a lot of, I hate to say personal preferences, but it will depend on how you set up your network, how you want to set up your network. Some people will start their IP addresses just in the range of IPs they want to assign. And what I mean is if you've got 200 clients on this network, you're not going to start at 1, and you've got 10 servers for those 200 clients. You may not start at 1, you might start at 11, and then assign 1 through 10 to your servers. I create the whole range, 1 through 254, and then I create an exclusion. And what this says is the server can't assign these addresses. So it won't send these out to clients. I know what my entire range is. I know which ones servers are. And then we'll talk about another one in just a minute that's another little in between those two.
And to address something that you just brought up, typically clients will receive a DHCP address. Servers more frequently get a static IP address.
Yep, I'm going to assign it by hand on that box and not let it get something from DHCP. There is another option we're going to look at that may change that a little bit. So the lease duration, again, you can set this. The default is 8 days. It is configurable in a broad range. It's going to be largely up to your network design and your network requirements. Options, I can set those additional options we talked about. Yes, I want to configure them now. This is where I'll set up a router. And in this case, I'll do 254. That's how I do it. So that's the address that all of my clients are going to get as a gateway out to the internet or other networks. Domain name and DNS servers. This one's nice. It gives me a parent domain. It says to configure scope, enter the IP addresses for those servers. I already have IP addresses. Where did it get these from?
Magic.
Yes, Magic. Microsoft builds lots of magic into their software, so things just happen automatically. We don't really know why. These came from my network adapter on this server. I've assigned DNS addresses, so it's pulling from there. I could take these out. I can use this to resolve the IP addresses of what might be my DHCP servers. If I don't know those IPs, this is kind of a handy tool. It gives you a bunch of different options. I'm going to leave this as is for now. Win servers, we're going to skip right past that one because we don't use wins. I don't anyways. Yes, I want to activate this scope now. Okay, done. So I've now activated the scope. It is ready for clients to use. Notice I still have this red arrow on my IP4 on this server though. I have not authorized this server to start issuing IP addresses on my network, and it gives you this information right here on the main screen. Must be authorized in Active Directory before it can assign IP addresses. This again is to protect your network from rogue DHCP servers. Authorization is a security precaution that ensures that only authorized servers run on your network. So I'm not going to do that because that will mess up my home network, but that's creating a scope. I now have a pool. I have leases. Now, in this case, I've actually made a mistake because I assigned in my scope options a router of 254 and did not exclude it from my scope. So I could potentially, in this configuration, create a conflict and lose some sort of network connectivity at some point, potentially for my entire network. Address leases, this is where, as your computers take on leases, they'll show up. I don't have any issued yet. This is what I talked about, the happy medium or reservation. This is where, within the scope, you'll see it says IP address 192.168.1. It's using the subnet mask I attached to this DHCP scope. I can tell my DHCP server to give a certain device with a certain MAC address, a certain physical address. Remember, those are unique globally, in theory, and they don't change. They're assigned to the hardware of every network interface device. So if it's a printer that's plugged into the network, it has a MAC address. I can get that MAC address. I can assign that MAC address or put that MAC address in right here. And what'll happen is anytime that printer comes online, it does the same thing a computer does. Are there any DHCP servers out here that are ready to give me an IP address? My DHCP servers are going to go, I have that MAC address. This is the address you have to have. And it's going to issue that same IP every time.
And the nice thing about this is you can use your DHCP server to centrally administrate all of your IP addresses. Mm-hmm. So whether it's a static IP address, a dynamic IP address, static IP addresses for specific devices, like you said, printers, servers, maybe routers or anything, You can manage all of this within the DHCP service.
Yep. I use this for printers. It's on the networks I was managing years ago when they were smaller networks. I would use this to manage network printers because it was an easy way to maintain a list of network printers. Supported both types, DHCP and VoOP. We're not going to go into these details in this course. This has to do with the routing of DHCP request and response traffic across routers. By default, DHCP traffic is non-routable. So I can't get a DHCP address from a computer to another subnet that's connected to my network. I'll add a reservation, why not? Close that, there we go. Scope options, again, we saw router and DNS. And then policies we're not going to cover. Server options are the same as scope options in terms of what they cover. So you see 003 router, 006 DNS. I can set that here as well. Router, DNS. The difference is server options are going to apply to every scope. If I don't set those options at the scope level, they're going to apply. If I set them at the scope level, they're going to be overridden. So,
which brings up a good point. You can set up more than one scope.
Absolutely. I could set up as many scopes as I want to. And they don't have to be anywhere in the same realm in terms of this. They can be different subnets, they can be different subnet masks, they can be completely separate. In this case, we're going to exclude the first 100. Let's make this 1 day. Let's say this is a secure network that we need more rapid DHCP response times. I'm not going to worry about these options for time's sake, but I now have 2 scopes on my server. And in this case, this one, no red arrow, because it's been activated. This one, I have to activate. So that's scopes. I think that's pretty much all I have. We have IP6 as well. You'll notice there aren't, I'm not going to go into IP6. It's a separate conversation and a much more broad conversation about network technologies and the use of DHCP in the first place. So this one's just for 4. And that's it. We've created some scopes.
Very nice. A PIPA. So we talked in a previous module, I believe it was TCP/IP, about a PIPA is the protocol that allows for automatic private IP addressing. So as a device comes up, if it's unable to receive an IP address, it can automatically get an assignment. This works for small office, home office, so basically SOHO networks, without deploying the DHCP service. A PIPA can get in the way of clients obtaining IP addresses from overloaded DHCP servers.
That actually, there's kind of a side note to that, in that if you've got clients on your network getting a PIPA addresses, but you've got DHCP in place, it's not that a PIPA is in the way, even though that's how we've worded it. It's that your DHCP servers are overloaded. So that's actually a good indicator of a different kind of problem. It's not that your DHCP server's down, it's that your DHCP server has too many requests to handle. It may be time to add a scope, add a server. There may be multiple ways you can troubleshoot. But just in case, to prevent the assignment of a PIP addresses on your clients, if the DHCP servers are unavailable or overloaded, you can disable it in the registry. We put this slide in here. I can do a little demo real quick. That was my original intent. But it was more just for warning's sake. We don't put the normal, I usually put a big red warning on any slide that says registry. Given that this is a network fundamentals class, you may also be new to the registry. Be very, very careful in the registry. You can do irreparable damage in the registry, and I have done so on a couple of occasions, always in a test environment, never in production.
Well, and the registry, if you damage the registry, you can keep your computer from booting up. You can damage services, and you can basically disable networking.
Yep.
And no longer have networking working. There's all kinds of damage that you can do within the registry.
But it's a fun slide. It gives you an idea. You can see what the registry looks like. You can kind of get your first, if you're in a test environment, you can play with what the registry looks like, how it works, go in and change that setting so that you can turn off a PIPA, and you can test it.
Well, and so we've talked about classroom environment. The nice thing about the classroom environment is you might actually have the opportunity to play with this.
Absolutely.
So you could go in, and I don't remember what class it was, maybe it was a Windows client class, where you would go in and manage a registry entry, bring the client back up and, oh, all of a sudden networking doesn't work. Go back in, change it back, now networking does work. So it really showed you the impact of what would happen if you basically didn't work with the registry correctly.
Yep. You can do some good damage with the registry.
Yes. Yeah, you can shoot yourself in the foot at about the head.
That's true. Yeah.
Not optimal. Okay, remote desktop services.
I feel like maybe this topic you have some good insights, some good information on this one.
Remote desktop services, near and dear to my heart. I have to say, I kind of enjoy me a cup of remote desktop services.
It's been a few modules since your intro. Maybe you want to talk about why that is. Why is it so near and dear to your heart?
The reason remote desktop services is near and dear to my heart is because that's the role service I've been working with for the last 5 years.
Nice.
So, remote desktop services, formerly known as terminal services. So, in 2008 R2, terminal services was renamed to remote desktop services to basically show or illustrate all the additional functionality the remote desktop services had. Terminal services no longer encompassed all the goodness that was now part of remote desktop services. And I don't think they wanted to just rename it Terminal Services Extra Goodness. Didn't quite work, so they renamed it Remote Desktop Services.
They should have. They should have gone
Terminal
with that.
Services Extra Goodness. So basically, I've talked about the name a bit, but I haven't really talked about what it does. Remote Desktop Services, its functionality is from one computer. You can basically remote into another computer, and you've seen Christopher do some of this, and take control of it as if it were local. So now a remote system appears to be local to you. Remote Desktop Services has, I wouldn't say different components, but there's multiple aspects of it. One is a session-based system, and that's remoting into a server. So the server having the ability to manage remote sessions. Each user has their own session. The issue with this is all clients are working in a remote server environment, so it's a server environment. So you may come across compatibility issues. All applications may not work effectively in the client or the server environment. So there's also virtual desktops. Virtual desktops is new since R2, 2008 R2, and basically what virtual desktop enables is the ability to remote into a client that's a client operating system. So now a user has access to all the full capabilities of a remote client. If you look at the slide here, you'll see the remote desktop services architecture. This is a poster specific to 2008 R2. It's an awesome poster. I want to show you something here. Okay, so let's go to the desktop really quick. And on the desktop, I want to come to a program that I've installed. This is Server Posterpedia.
I think you have to,
I have just been informed that let's see, I need to duplicate my screen. I didn't have the screen duplicated. Okay, there we go, score. I have the success signs from the back. The back of the room's going crazy. So now you can see Server Posterpedia. This is the default view here. What is Server Posterpedia? That's a good question. Server Posterpedia are posters of all the different systems that posters have been created for. It is a Windows 8 utility, so if you go into the Windows 8 store, you can download Server Posterpedia. And why I'm bringing this up is let's go into Remote Desktop Services here. Well, here's Remote Desktop Services, but there's also Hyper-V, 2012, 2008 R2 with SP1, features and technologies for Windows Server, Active Directory. So there's a lot of different technologies that are represented here. let's go into remote desktop architecture here. Let me blow this up a little bit. Oh, not what I wanted to do. Let's blow this up here. And basically what we have here is this middle chunk here overviews the architecture for remote desktop services. The rest of the components here, let me zoom out a little bit, hopefully not getting too dizzy here. These other tiles show you the different components of remote desktop services. Remote desktop services is made up of, let's see here, 1, 2, 3, 4, 5, 6, of about 6 or 7 different roles and features that come together and are installed that allow for this functionality. So I just wanted to show you this poster, show you this utility that really demonstrates architecture and is a great resource for learning about these different tools. So let's go ahead and go back to the slide deck here. Where's the deck? Is that? Okay, so that's
it's in there
the
somewhere.
deck.
Keep looking for it.
And let me go back to extend. So hopefully now we are...
No?
No, okay, I'm getting the no. It is not. We are experiencing a slight bit of technical difficulty.
There we go. I think we're good.
Oh, we are, except now, let's see here. I don't have my... Okay, this is awesome. We have...
Go back to extend. I think you're in duplicate.
Show presenter view.
It takes a second.
Okay.
There you go.
Okay,
Ta-da.
we have success.
We're all
Ta-da.
good.
Huzzah! Okay, so showed you the remote desktop services architecture. I showed you the poster. Server Posterpedia, if you haven't downloaded it from the Windows 8 store, you can. You can also download, if you're not on Windows 8, you can download those posters individually as PDFs from the Download Center.
So for some bonus information, who authored that RDS poster?
Excellent question, Christopher. Let me see, who authored
indeed?
that poster? Oh, that's right. I helped author that poster. Martin McLean, poster guy, Brian Litch, additional RDS technical writer at that point, and myself, we all wrote that poster. So download the poster. We don't get paid for it. And again, a big hug of knowledge for you.
That's right. They're free.
They're free, and they look really cool hanging on your wall.
They do. I'm actually a huge fan of the component posters.
The component posters, huge geek cred.
Absolutely.
Huge geek cred. Okay, so now let's go to remote desktop connection. I have multiple remote desktop connection here. You're probably familiar, if you're familiar with remote desktop connection, with the upper right here, the remote desktop connection tool. From the command line, you can run MSTSC, Microsoft Terminal Services Connection. So this is the old style. If you look at on the left, that's the new modern client with Windows 8. So you can download that. It's remote desktop from Microsoft. It shows here that there's a remote desktop and then RD Web Services. So RD Web Services is the ability to go to a website, administrator populates that URL, and when the user goes to the URL and logs on, they just get access to all of that service. So all of those applications, any of the populated desktops, the user will gain access to it. Did you actually want to show a demo of this?
I did. So the reason I put demo on that slide, I added demo to that slide kind of last minute, so poor Thomas was unaware of my changes. I wanted to show what those two interfaces look like. I use the MSTSC interface quite a lot. It looks like this. If we see my desktop, this is the old one. If you do start run or you do command line or you do something MSTSC, Microsoft Microsoft Terminal Services Client?
Client, yeah.
Was the original initialism. This is what that looked like. You could put in an IP, put in a port, put in a username, change a lot of different information. I will give you a little bonus here to some RDP. Local resources, more. Drives. You can make local hard drives available externally.
In your remote session.
Potentially a giant security hole that your IT administrators may not know about.
Correct, but we could use group policy to crank that down.
Absolutely. So that's the old one, and then I wanted to do the demo of the new one. I actually want to grab it real quick.
So,
Remote desktop.
Yes. So Christopher's showing you going up to the store, having to download it.
Oh,
You are denied.
demo thwarted. Too many PCs in the live account. That's right. We'll skip this demo for now. But you've seen it. Go to the store, type in remote desktop. You get the same interface that he just showed you. This is what it looks like. This is the new and prettier one.
It's very nice.
It's also more functional. You can actually keep track of connections over time, whereas with the last one, all you see in that box is the last one you opened when you open up Terminal Services Client.
Okay, so notice from the screen here, you see desktops and graphics. As you exit the connection, it basically snapshots it and shows you what the last snapshot looks like. So it gives you a little bit additional information for that desktop.
Shows you where you left off.
Yes.
Terrific. That's all I had.
Okay, routing and remote access service, or RRAS. This supports remote user or site-to-site connectivity using virtual private networks, VPNs, or dial-up network connections. Dial-up. Remember when you actually had to pick up the phone, you got a dial tone? That would be what that's referencing.
What was that?
Yeah, dial a phone. Remember when you used to have to pick it up and dial the phone?
Weird.
Okay, RRAS consists of the following components. Remote access, so allowing the ability to access a remote system, and routing, so basically the ability to, from a local network, to connect to a remote network.
Turns a Windows server into a router.
Correct. And this was formerly known as the Remote Access Server, or RAS.
Yep, RAS is a well-known acronym that's still used pretty readily. People still call it RAS, even though it's Routing Remote Access Service.
Routing and remote access service. Again, another excellent graphic. Thank you, Christopher. Let's see what we have here. We have the client. We have a remote device, the internet ISP, so routers. We have routers on each side, the internet ISP, and then the server basically connecting.
Yep, so it allows us to connect a client to a server or a network over the internet. This is the remote access portion of this particular technology, allowing us to let clients into a network from outside over the internet without having to build our own infrastructure. Thank you, Internet, for providing that connectivity.
Thank you. Demo time.
Demo time indeed. So let me get this running again. And we will jump right back into the same environment. My 75 character password. One of these days I need to change that. So we're right back to the same server we looked at before where I had DHCP up and running. We'll go ahead and close this. I am again going to add roles and features. We're still on Server Manager. Next. Next, it's role-based, same server. And right here, so we see remote access. And we see all this. This one's much more than DHCP just wanted us to install a console. This one wants us to install all sorts of additional features. Web server, internal database, group policy management. We're going to go ahead and add those features.
And the nice thing that any supportive services that need to be installed get called out. So you're not of the idea of, oh, I didn't know what was installed. You can actually look on that and see, oh, IIS is installed. So you have an idea of what additional information will get installed.
Yep. Features. We have, again, a list of features that we can still install. We're not going to worry about this right now. Next. It does show us, let me go back to that. It does show us what was selected when that box popped up that said additional role features required. It shows us in here what it added. Group policy management obviously was one of those. Windows internal database was one of those. We can add our own if we want. Remote access, role services. So right here, this is where it gets a little confusing because it's called routing remote access service. In Windows Server Manager, you're only going to see remote access. It's when you get to this level, the role services, that you'll see routing as an option. So I want RAS, remote access, and I want routing so that we can see both. I'm not going to worry about IIS. It's installing its bare minimum, which is all I need, and install. It says, again, restart destination server if required. You can tell Server Manager to do your restarts automatically. I don't want to do that. Now here, I already have this little yellow exclamation mark, what we call a bang. Post-deployment configuration. This is actually from the prior one, configuration required for DHCP. You'll see this from time to time after you've installed a feature or a role, if the server does want you to do something to that role or feature to get it working. We'll probably see one right here after we install routing and remote access as well.
Well, we didn't, in the previous demo, you didn't authorize the scope.
I didn't.
So it's letting you know that, hey, there are still actions that need to be performed for this to work effectively.
Yep. And for now, that's all we're going to do is install it. So now that we've done that, we'll move on and we'll come back to another demo in a little while.
Okay. So we talked about routing and remote access. Now we'll talk about Internet Protocol Security, IPsec. So IPsec is a protocol within the TCP IP suite that encrypts and authenticates IP packets. This allows private or secure communication to occur over an IP network. Typically traffic that goes over an IP network. So in previous modules, we've talked about the postcard analogy. Filling out a postcard that had a data payload in it. Dear Christopher, I'm at the beach. I'm having a great time. Thomas. I put an address in there, and all of that, when I put that in the mail, anybody who sees that postcard can pick it up and read it.
It's called plain text.
And typical internet IP frames are clear text and can basically be read by what you would call a network sniffer.
Yep.
So a network sniffer or analyzer could pull these packets out and basically recreate a session.
Potentially.
Potentially.
It's a big network security risk, actually, that a lot of organizations have to fight against.
Yes, man in the middle.
Hence IPsec.
Yes, so IPsec allows for securing application traffic, resides on the network layer, used in conjunction with VPNs, integral part of IPv6, and there's actually two different modes for it. Tunnel mode and transport mode. Tunnel mode is used for creating virtual private networks. So creating a virtual private network between a client and a destination. So you basically create your tunnel, which we're going to talk about later. You're going to create this tunnel that enables communication. There's also transport method, and this is for encrypting the data itself on private networks. If you look at the graphic here, the IPsec protocol types, you see the protocol, there's authentication header, encapsulating security payload, or both. Authentication header, basically, if you need to be protected from modification and authentication, but you're not worried if the packet is readable. So now you're just ensuring that the packet isn't somehow modified. So a router that gets a hold of this, that basically takes it from one network and puts it on another, isn't injecting information in this.
Or a person.
Or person, exactly. So when the receiver receives this, they take a look at it and say, oh, okay, is this the packet that was actually sent? Is this the same? That's authentication header. Encapsulating security payload. Well, now the data needs to be protected by encryption, so it's unreadable, but the IP address can be left unprotected. And then both AH and ESP allows for both to be used simultaneously. DNS. We've talked a bit about DNS, domain name system, worldwide service that resolves a host name to an IP address. The DNS architecture is a hierarchical, love that word, hierarchical distributed database and associated set of protocols. This associated set of protocols allows for a method of querying and updating the database. So as a client, www.microsoft.com, what's my IP address? A mechanism for replicating the information in the database among servers. So I'm a DNS server. I have this information. Christopher, you're a DNS server. I can give this information to you to do a couple things. One, build fault tolerance. Two, offload all requests coming to me. Now some requests are coming to you.
Yep, potentially.
And then it also defines a schema. A schema basically says, hey, what objects and properties are associated with the database. It's application layer of the TCP/IP reference model, and use port 53 to accept name resolution requests.
Yep, we talked about ports. So, and this one's important in that if you're hosting your own services, hosting your own domains, you may have DNS servers running. You'll have to allow 53 inbound for external requests to get to those DNS servers, if that's how you've got it set up.
Okay. So DNS enables host name to IP address. WINS allows for NetBIOS name to IP address. We talked a little bit about NetBIOS already. It was implemented using, or Microsoft used the NetBEUI protocol initially as the default to allow computers to intercommunicate.
Yep.
NetBIOS was the naming scheme. I think they were limited to, what was it, 15 characters?
Yep, still to this day.
15 characters name. So WINS systems are DNS-like in that DNS does hostname to IP resolution. WINS does NetBIOS name to IP address resolution.
So it's similar to DNS, and then it's doing named IP.
Correct. Where DNS, the precursor to DNS was hosts files. So basically you just set up a file and create a host name and an IP address. So your client could look into this host name file and arbitrate it itself. DNS automated that. For WINS, it was LM hosts files. How do we get to the summary already? We're at the summary. We've talked about being able to install and configure DHCP. We've learned about Dora, the explorer, not the fish.
Not the fish.
Not the fish. We've talked about installing and configuring remote desktop services and that really cool poster that you should go get now, Server Posterpedia,
Yep.
and downloading the individual posters. We've talked about routing and remote access, how to use IPsec in your environment, the various protocols that can be used. And we've talked about DNS and WINS. And in most environments today, you're not going to use WINS.
Nope,
you're
DNS only.
You're going to use DNS.
In fact, DNS, I'll give a quick summary. DNS has a new feature as of either 2008 or 2008 R2 that allows for the sort of mimicking of WINS functionality to allow for backwards compatibility with systems dependent on WINS so that you can remove WINS from your networks.
Oh.
So it's called global names. There's a global name zone. It allows for what's called single instance naming. If you just want to put a name and an IP instead of a name in a hierarchy, we mentioned DNS is hierarchical. You'd have to have name.domain.something. Like I've got server.ctg.local, Christopher.test.network, whatever the case may be. WINS doesn't use that. WINS just uses server or Christopher or Windows 8, whatever the name of that host is. DNS has a mechanism called global names for accommodating WINS requests now.
Oh, and really quick, for more party knowledge, we've been talking about network services. A lot of these network services are IP-based. To learn more about IP-based services, RFCs, requests for comments. Requests for comments are the standards papers that create these utilities. Some are funny. I mean, I've seen some that were kind of written like 'Twas the Night Before Christmas. So some are kind of humorous, some are odd, and some of them are very, very technical. But they basically define the standard of WINS, DNS, and all the anything TCP/IP related has been defined by an RFC.
Yep. I use RFCs. I use specifically the IP6 RFC to fall asleep if I'm ever unable to. You just start reading about IP6 and 5 minutes at most.
Out like a light.
Yeah, those RFCs can be, you say they can be fun, they can also be a little dry. A little bit.
Christopher, additional resources and next steps. It's that time.
All right, one more time. We've got our book, MTA Networking Fundamentals, Microsoft official academic course. We've got our instructor-led courses, 4 different options. One of them is just the course that we're sort of teaching here, but in an instructor-led, peer-present classroom environment where you may get more hands-on experience. And then we've got our exams and certifications, which is usually the intent of these programs. 98-366 Networking Fundamentals, Microsoft Technology Associate Certification. Almost forgot what we're teaching here today.
And then also a link for the remote desktop poster that I showed. If you want to go to the download center, www.microsoft.com/download, you can look up these component posters, Windows Server, Hyper-V, SharePoint.
Let's do a search for poster.
Azure.
It works really well, actually.
Yes, yeah. And it's a really great way to visually represent the information a little bit differently.
Yep.
So you can kind of see architecture information and how things fit together a little bit better.
Yep. It's a good tool. I guess we'll be back for more in a little while.
We're at that backslide.
We are.
Again, I'm torn. I'm happy that we've covered some great information. I'm a little sad it's over.
I feel like maybe you get a little emotionally invested in
I
these.
do. I want these people to have good information.
That's
and,
good.
And we're done.
That's why I make it a video. It's what's the word I'm looking for? I can't think of the word that we're posterity. We're recording this for posterity.
Yeah.
You can even come watch it yourself anytime you want.
I might. Talking about putting ourselves to sleep.
Oh, I certainly hope not.
So, MTA, networking fundamentals, networking services. I think that about wraps it up.
For now, yeah.
Yeah.